Okay, take it away, James.
Hello, hi, I am James Dibler. Today we are at the DARE Conference 2020 meeting. We are talking about how you import the machine and how to count it. The presenter is Kendall Jackson.
Hi, everyone. So let me just share my screen here. Great.
Here is a slide that Kendall Jackson talking about employing machine learning models to production with AWS SageMaker. He will explain the PowerPoint about how the process works.
So my name is Kiowa Jackson. I'm a machine learning engineer on the data innovation team. And today's topic is deploying machine learning models to production with AWS SageMaker. So objectives for today is to give intuition of the structure of an end-to-end machine learning production pipeline. I know some people might be familiar with machine learning, but not everyone is familiar with machine learning. Have always had experience with production pipelines. So I just want to give a high-level understanding of how those work. And then within that context, explain how SageMaker fits into this. So some of you might have done AWS workshops, and I know when I started learning about SageMaker, I did some of those. They tended to fly through code that did a lot of cool things, but I couldn't, in the beginning, it was hard for me to understand what that actually meant in practice and how it actually worked. So I'm going to try to take a slightly different approach and explain it more from a high level. I still recommend the AWS resources that they have, but hopefully this can complement those. And hopefully this will also spark some ideas for use cases. Maybe you've been thinking of some machine learning projects already, and this gives you an idea how to bring those into life. Or maybe you just get a new idea completely based off of what we talk here. So we're going to start off with doing a poll on experience level. It's just for me to kind of gauge where the room is at, so I know how to kind of pace myself and what to focus on and what if any, we could skip. So the first one is your level of familiarity with Amazon Web Services. It looks like a fair amount has never used it, which is good because that's kind of what I made the presentation for. So we'll make sure that to bring everybody up to kind of the same page before we dive into the SageMaker stuff. So we'll talk a little bit about how AWS works at a high level before we dive into the SageMaker details. Let's see. Yeah, I think this is enough to get an idea. So we've done, okay, we have a couple of certified here. Okay. I think we can do the next poll. So with regards to machine learning, what is your level of experience? From never used it to maybe you put some in production, maybe you've taken some online courses, so you have an idea of the theory, but you never really put it into practice. Okay, and this one seems to be fairly spread out, but we have a couple of people, a fair amount of people that never used it. So, okay, so I'll make sure to take that into consideration. Okay, great. I'm just going to end the poll and we'll get going. So the first thing we're going to talk about is serverless pipelines. We're going to talk a lot about those throughout this presentation. So we're going to start talking about what that means. And those are words that come up a lot. So first, talking about machine learning pipelines. Machine learning in general typically involves many pre and post processing steps that have to happen in a certain order. And it's critical that the data used for prediction is processed the exact same way as the training data, or you're going to end up getting results that are different. So because of this, there are many moving parts when retraining and redeploying versions to the cloud. So SageMaker can help us manage that process in a scalable way. For us to understand what AWS does, and for those who have no experience with it, there are a couple of core services that we need to just cover before we can get going. The first one is Elastic Cloud Computing, EC2. It's a virtual machine in the cloud. You can basically think of it as a laptop that you access remotely. You pick the processing power, operating system, and other configurations. And based off of that, you can just start, stop, and delete as needed. So you see the cost here on the right. So based off of how much compute power you need, it will cost, there will be a different pricing rate per hour, but it gives you the freedom to really set things up. So you can choose, I need a Linux box, or I need a Windows machine, and I need this pre-installed, and then you just kick it off and you can use it. Many services that we're going to talk about run on EC2 in the background. So SageMaker, you might have do a batch processing job. What you're actually paying for is the EC2 instance that runs your code and reads your data. So that helps a little bit with understanding, getting an intuition for what the cost and what's happening in the background. And we'll talk more about pricing, because I don't usually, but when people are new to AWS services, it's something that's a concern, and rightfully so, because if you don't use it the right way, the cost can go up. So we'll cover that. That one is S3, so simple storage service. Very cheap storage, organized in buckets with folders. You can think of it basically as Dropbox, but more scalable for larger size data. In SageMaker, all input into SageMaker needs to live in S3, and all the output goes to S3. So you will put your data into S3, SageMaker will pick it up, put it through the pipeline, the machine learning pipeline, and then post it back into S3 where you can pick it up and do something with it. And usually what it posts back is a set of predictions that you can use in your application. The third part is AWS Lambda. And it basically allows you to just write code in an editor, and AWS provides the compute for that behind the scenes. It's really useful for creating small scripts that need to run on queue. Usually you have to, if you want to do that, you want to have something run every morning, you have to set up a server to kind of to run that script. Here you can just write the code, post it, or deploy it, and it just kind of runs magically. It's containerized. I won't go into too much detail about that, but it's just you need to kind of provide all the dependencies that script needs to run. And that's a theme in general with AWS, is that everything kind of lives in this containerized environment. If it needs additional resources to function, you need to provide those. But basically, in summary, you have EC2, a virtual machine that you rent. You have Lambda functions, which are scripts that run in the cloud. And you have S3, which is cheap cloud storage. And so an example of a very simple serverless pipeline would be some sort of S3 event, some sort of storage event that kicks off a Lambda, and then maybe a second Lambda takes over. And an example of that might be that the data warehouse posts the CSV file to S3. And once that file gets posted, it kicks off a Lambda that picks up that file, computes statistics, and then hands it over to another Lambda that summarizes it into an email and sends it off. And those two Lambda functions will then run on EC2 instances. And this is a completely serverless pipeline then. So all you have to do is write these two scripts, give them to AWS, and then also define the S3 event. And you can have that set up and run daily, and you get your email with your statistics. So this is the simple end, and then obviously you can go more complex than that. The other concept that we need to make sure everybody understands is the concept of microservices. And this can be a bit daunting at first when you're new to AWS, because this is just a small selection of all the services that they have. But the idea is to stack many smaller, highly specific services into a custom application. So for example, you can use Amazon Transcribe. I see there's a couple of, so you can use Amazon Transcribe to convert voice command to text. So basically, Transcribe takes an audio file as input and outputs a text file which contains a transcription of that audio. Amazon ALEKS can then take this and map this to an intent. So you can map whatever commands you have, and you can set those to map those to a particular action that you want AWS to take. And then you can use Amazon Poly which is a text-to-speech service, to read back a response. So if you add a Lambda to that actually does something, if you have a script triggered with this, basically what you have is the basics of ALEKS service. You can ask something to it, it transcribes it, maps it to an action, kicks off a function that does something for you and reads back a response. Or you can use AWS Translate, and now you have a translation app. So there's many cool ways, once you get used to this idea of microservices, there are many cool ways that you can combine those and make quite sophisticated applications, and without having to build everything yourself from scratch. And it's not unusual for a project to involve many of these microservices. And like I said, it takes some getting used to, but once you are used to it, you can get a lot of things done really quickly with very little setup work. So summarizing the whole intro before we jump into SageMaker, we have something called pipelines. These are sequences of processing steps. It includes model training and prediction. We have serverless, which is the idea of running applications on virtual machines in the cloud instead of on your laptop. And we have microservices, which combines several highly specific services into a custom application. So with that in mind, we're ready to look at SageMaker. And what is SageMaker? It's a collection of services for managing the development and deployment of machine learning models. So each service that falls under SageMaker handles a sometimes complicated step in the pipeline. So it's a little bit different from microservices. A little bit different from microservices in that these are meatier, so a little bit meatier tasks. So this might be train a model, it can be tune parameters, can be deploy, and so on. But the benefit that it brings is it makes your machine learning process reproducible and repeatable. And it makes it easier to manage these at scale once you want to scale up and actually do something with it and put it in an application that you hope to grow. So the first thing I like to tackle before we go into the good stuff about SageMaker are the initial challenges that you likely come across if you want to explore and start playing around with SageMaker. The first is it needs some setup work. So you see here this little code snippet here. This is a random forest classifier, which is a type of algorithm that you can fit to data. And here I fit it to some training data. And what I get back is a classifier, a random forest estimator, and it's ready to be used to make predictions. Yeah, assuming I've already prepared the training data, this is literally just one line of code. There's a package called Scikit-Learn. I'll talk a little bit about that later, but it's just a single line of code when you do it on your laptop. If you want to do it via SageMaker, you have to add a bunch of stuff. You have to tell them where to find the input files, where to put the output files, what EC2 instance to use, and a bunch of other things. So it actually requires some more setup initially. Another thing to be aware of is that they run on EC2 instance. So it takes time for certain tasks to be completed because in the background, it's going to spin up one of these virtual machines before it can even start running your code. So if you use SageMaker during early debugging, it's going to add a lot of time for you because this line of code in the top, it runs in a few seconds if you use a small sample file. But on an EC2 instance, it's going to take 4 to 5 minutes for it to start, and then it's going to run in a few seconds. So if you use it at an early stage while you're still figuring out the basics of your code, and you're still dealing with things like you might have a misspelled function here and there, or forget to close a parentheses, and dealing with all those little small bugs that you work out in the beginning, if you use SageMaker during that part, you're going to slow down a lot because you're going to be waiting for these EC2 instances to start the whole time, and then each time they will just throw an error. So it's just a matter of right tool for the right job. And where SageMaker really shines and where it really starts, you start notice the benefit is after you deploy it. Once you have the basic kinks worked out and you're ready to start moving and actually doing something, that's where you get the benefit back. So with that in mind, let's talk a little bit about the features that SageMaker offers. So we're going to start talking about the tools that it has for model development and training. There's something called Jupyter Notebooks, which are really popular in data science. And they produce visualizations that goes in line with the code, and it creates a really easy to follow analysis process. You kind of follow the work that was done, and you'll have output along the way. You can follow the thought process of the analysis, and then all the way down to the output of the model. So these have become kind of standard in the data science world. And what SageMaker offers are notebook instances. And these are Jupyter Notebooks that run on EC2 instances. And the benefit that you have there is you can just choose the underlying EC2 instance. You just decide how much power you need. And if you're running this and in the middle of it, you run out of memory. If you have a laptop and your laptop runs out of memory, you need to buy a new laptop or buy a new RAM. But here you can just switch to a larger processor. You can start small, doesn't work. You can do a larger one and so on. So that's really useful. The other good part is you can swap between pre-installed frameworks, and it has all the basic stuff, but let's say you want to do something a little bit more advanced like deep learning, and that can a lot of times be a little bit of a shot in the dark if it's going to work for a particular use case. And if you're doing it on your laptop, it requires a lot of setup and installing software, and there's a lot of versioning issues and things like that. On these notebook instances, they already have these pre-installed, so you can just switch very easily if you want to test something out real quick, see if it's going to work for you or not. If it doesn't, you can just move on and use something else. Another benefit is that these obviously run independently. They run on different EC2 instances. So what that means is if you're working on multiple projects, and one project you're running a heavy training job that takes a lot of resources. If you're on your laptop, it's going to slow you down if you want to work on anything else. But here you just run a completely separate instance. You can run a really heavy load on one instance and just go off and work on something else while that finishes. So a couple of words on notebook instance cost and SageMaker cost in general. The cost of a notebook is the cost of the underlying EC2 instance, and that goes for almost all of the SageMaker's services. And if you want to compare that, get some idea how that compares to having a regular machine, a regular notebook, you can think about that normally you need to buy something for the highest processing load. So let's say you have truckloads of data and you need to get that in a model and train it. You need to buy a laptop that can handle the most complicated and process intensive part of that process. But in reality, most of your project, you will not be using max capacity. That's usually just for the final training part. The rest of that, you're going to be doing stuff like debugging, setting things up, and you can use just a sample of the data to run it quickly and run it on a smaller instance. So this is where there's potential for cost savings with SageMaker, depending on your situation, because you can use most of the time, 95%, you can get away with using a very, very cheap machine. And then when you need to do the more heavy lifting parts, then you can switch up to something a little bit more powerful. And you see here, this is 6 cents per hour, and it goes up by 100 once this is kind of a monster, but it goes up by 100 to $6 an hour. And obviously, that's really expensive, but if you use this for 95% of the time and only use this as needed, then the cost, it might work out that that's cheaper than having to buy a laptop where you have to replace every couple of years and then upgrade and so on. So that's for the cost and for doing the model development, sort of the environment that SageMaker offers for you to develop your models. Then they have things called SageMaker Training jobs. And those are, is it type clear? Yes, it does. So I have a question here. Does upgrading the instance type clear the memory inside the system? Yes, you have to end the session that you're in, upgrade it, and then start it back up. What size ECR do you typically end up using for your models? Anywhere between medium to large to extra large, usually somewhere around there. Usually medium I can get away for using samples, and then when I use the full data, we don't have at ASU yet in the projects I'm involved with, the data sets haven't been huge. Usually large and extra large, depending on what I'm doing, is fine. Sometimes 2x large. So SageMaker training jobs offer, they have the nice benefit that they leave a paper trail. So a lot of times, maybe you need to return to something you did last year and kind of understand what you did and you want to test that. It can be really challenging sometimes to recreate old training jobs and get the same results and reproduce them. Maybe you read something, that particular model was using a table and that table has been changed or updated in some way. That means your output is now going to be different. But SageMaker have these kind of self-contained training jobs, which stores snapshots of the data. It stores the snapshots of the data that was used because it lives on S3, so we'll just have a link to that. It stores metrics and diagnostics and things like what parameters you used for the model. The other benefit it has is it's scalable, so you can run things in parallel. So for instance, if you have a training job, in some cases, we have hundreds of models that need to be used. So for instance, the project I'm working on now, we're using weekly models, and we have like 15, 16 something segments that we need to train individual models for. So they add up to about 200-300 models. And if you run those sequentially, and each model takes a few minutes to train, very quickly you'll look at very large training times. But for SageMaker, you can run these in parallel through AWS, run them in parallel. So they can all be run at the same time, and the cost scales fairly linearly. So it's about the same cost to run 100 jobs sequentially on an EC2 instance versus spreading them out horizontally and run them all in parallel. SageMaker also has, when it comes to training and development, has something called AutoPilot. And it allows you to test out combinations of processing steps and algorithms and evaluate performance. So what we're seeing here on the right is an example of a pipeline and all these different steps that go into pipelines. You can see multiple pre-processing steps here. We're scaling, we're one-hot encoding, and in the end, you're applying a specific model, in this case, logistic regression, to fit towards that. And what AutoPilot does is it swaps out these processing steps, different models, different pre-processing steps, and it tests out what has the highest impact on your, gives the best performance on your data. So this can give you a very decent candidate just right out the box. You just give it your data and you get back an optimized model which tells you what parameters to use, what model to use, and so on. Sometimes this may come at the cost of interpretability. It turns it a little bit more to black box. So for instance, PCA there. I'm not going to go into too much detail, but it basically reduces the dimensionality of the features. So it combines features in certain complex ways, so you can use a smaller set of features. And that can improve your performance, but also makes it a lot harder to understand what it means. Because now you're dealing, instead of dealing with features like age and demographics and things like that, you're now using these components, which are much harder to interpret and much less intuitive. But AutoPilot can give you a quick thumb in the wind and kind of give you an idea of what the potential for the model is and kind of where it lies with the current data. So it can definitely be useful in that way. Right, one thing I was going to mention here is that this pipeline on the right is actually a Scikit-Learn pipeline. It's not a SageMaker pipeline. I'll get back to, we're going to talk more in the next slide of what Scikit-Learn is. But I just want to highlight here that usually pipelines are associated mainly with development, with deployment and having things in production. But they can be really useful during the training and model development part as well, because it allows you to kind of keep track of these combinations of processing steps and allows you to test different permutations of them. So if you're using machine learning, but you're not using Scikit-Learn pipelines, I highly recommend you check them out. So a little bit of a side step, Scikit-Learn is not technically a part of SageMaker, even though you probably will end up using it within SageMaker. But for those who are unfamiliar with machine learning, it's basically a suite of tools that you can use for modeling and pre-processing and so on. And for those of you who may have more of a theoretical background on machine learning and haven't used much for application, their user guide is actually really good for getting an idea of how things apply in practice and how you do things with code. It also works great as sort of a checklist to go through to get ideas for things that you can try out during training and development. SageMaker also offers hyper-tuning jobs. So hyperparameters can improve the model further. There are sort of additional little knobs that you can turn and tweak and set to different values. There are lots of parameters with lots of potential values. There's certain models like XGBoost are well known for having a very large set of hyperparameters. So the list of potential values can quickly explode. And when you use something like Scikit-Learn, usually you use something called grid search, which is basically this brute force where you test every possible combination. And in addition to that, you're probably also doing something called cross-validation, which means you train the model multiple times on different cuts on the data to kind of get an average that's a little bit more robust. But with that many possible combination and multiple passes on it, it can sometimes explode into a very large number of combinations that's going to take a long time to process. So SageMaker uses something called Bayesian search, and all you need to know is that it basically makes guesses about what parameters is going to have the biggest effect on your performance and tries them out, and then iteratively kind of searches down to try to find the best parameters. So it doesn't do an exhaustive search. It's more of a guided search. But that's another product that they offer that can save some time. So that's kind of everything for the training side. And I know a lot of people, in a lot of cases, people will have experience with training the models and evaluating them on the test data, but there's a lot of instances where projects don't go further than that. So it's often the case that, or it can be the case that people have experience with training and evaluating models on the test data, but they haven't really had experience with what happens after that once you move it into an application. So we'll talk a little bit about the challenges of that and what SageMaker does to help with that. So first of all, you have inference, and basically inference is when you have the trained model and you apply it to new unseen incoming data. So you have a model here, and this model now lives in SageMaker. It's already trained. It already exists. And you have some feature. You get feature input from a student, and you pass it through the model, and out comes a prediction. So the way that works in SageMaker, they have something called real-time endpoints versus batch predictions. So a real-time endpoint, the SageMaker endpoint, you can access that by an API gateway, which basically means you can, in real time, take a bunch of features, post it to this endpoint, and right away you get back a prediction. Really helpful, for instance, if you're doing lead scoring or things like that, somebody fills out a form and you immediately want to get a score of that lead so you can prioritize that. Endpoints are great for that. They're also scalable, so they can handle, I think, 10,000 requests a second or something like that. Batch predictions is when instead, when you don't need something in real time, you take a full file of records, give it to SageMaker, it runs through all of these, and then returns a batch of predictions for that. So when you're not needing things in real time, the batch predictions is what you will use. So normally you would have to set up a server, especially for endpoints, you have to set up a server to handle that, but obviously AWS handles that portion for you. It also has the paper trail and logs to help debugging. So again, you can return later. If I want to know why a particular student last year got a particular prediction, I can follow the paper trail here to see the model that was used, a snapshot of the input data. I can also see exactly what happened in the logs at that endpoint and what drove the prediction that was given. One side note and a word of caution is, for the most part, a SageMaker is actually really cheap. There's a very low risk of having runaway costs except for these endpoints. Each endpoint will sit on its own EC2 instance. So if you're training hundreds of models and you're evaluating these models by setting up an endpoint for each model, it means you all of a sudden have hundreds of EC2 instances, and you can talk, it can be cost like $20, $30 an hour. And there's nothing built in AWS that will notify you that you have this many endpoints. So unless you go and specifically check for them, they will just sit there in the background and run up. So my advice is to anybody who's getting started with SageMaker and trying it out, just use batch predictions and stay away from real-time endpoints. It's just very specific use cases where those are needed anyway. So it's a lot safer that way in terms of cost. Another really, and this is fairly new, I think it came out end of last year, is Model Monitor. And it addresses an issue in data science that models don't break, they tend to degrade. In software engineering, if something doesn't work, it usually throws an error and you can see a big red warning and everything, you can immediately tell that something is wrong. A lot of times with models, if something is wrong with the data, it would just start skewing the predictions and it might not be immediately obvious that it happened. So it can go through and be and not be caught right away. So Model Monitor can make distribution checks on incoming data and alert you to changes. So in general, and almost by definition, whenever you see weird production output, it's due to a change in the data distribution with respect to the training data. It can be the model itself sometimes, but the model, once you have a trained model, it's actually a pretty simple object. It's just, a list of weights and how to weight the features together. The complexity is usually in the data and the pre-processing, and that's usually where it will cause some issues. So examples can be that, for instance, now with COVID, maybe you have an audience that's significantly different from the training audience, that more people are online. And this is totally valid, but it's good to be aware that you have that difference in distribution. But there can also be other mistakes like percentage points changed to decimals. So if we're using percentages to evaluate student performance on test scores, all of a sudden it's going to look like all students have scored less than 1% if you make that switch. And again, all that will happen if you put that into a model is that the predictions will start getting skewed, whereas something like Model Monitor will actually catch that there's something up with that and something has changed. Another problem is NAs, which are missing values. And most pipelines are set up to handle those. They impute them with, for instance, zeros or median values or remove them altogether. But what that means is if you have some issue where there's an issue with joining two tables together and it produces a lot of NAs, that might just flow through the entire pipeline and go unnoticed and start skewing the results. So again, it's good to have something like Model Monitor that can help manage that and stay on top of that. There's also a concept called model drift, and it's the idea that models get slowly outdated once you train them, and performance will start degrading over time, and you can set up warnings and triggers through Model Monitor that a threshold that once performance drops to a certain level, you retrain the model and launch it again. Some words on other services that are available in SageMaker. So we have SageMaker Ground Truth, and it's basically crowdsourced. Oh, let's see, I have a couple of questions. Let me, So the pilot point and click tool. Yes, it is. So everything, all the services that I mentioned tend to be, they have both there. You can do them both through the UI that I'm screenshotting and showing, but you can always also do it through the API and do it code. So someone was asking if AutoPilot is point and click. It's both. So you can use it through your code. Actually, that's a good question. I'm not 100% sure about AutoPilot. I would have to follow up on that. It's typically the case that you can do both, but I'm realizing now that I'm not 100% about AutoPilot. Are paper trail logs version controlled? If I make changes to my script, will I have the ability to see past logs? Yes. So logs are self-contained and they get stored at the time of processing. So you can go back and see whatever whatever happened in that log at the time, you will have to kind of cross-reference it with what script was pulled by, was used to process the data. But through SageMaker, that you'll have all those parts. You'll have the scripts that were used, that will sit on S3. You have the data that was snapshotted. So you're able to go back and piece those things together. So ground truth is crowdsourced data labeling. So what that means is you can basically upload your data, and when you're using supervised learning, and this is mainly for computer vision and natural language processing tasks like sentiment analysis, and you need a bunch of examples for the models to learn on. So for instance, neural nets need a large amount of data, and someone has to label those. If you want to do sentiment analysis to determine if student feedback is positive, negative, or neutral, you need a bunch of examples of those. And someone's going to have to go through and actually create that labeled data. So ground truth is a service that AWS offers where you can outsource that to workers, and you just provide the instructions. So here, in this example, they're requesting that you draw bounding boxes around cars, and you can upload a large data set of cars. They draw bounding boxes, and then you can take those back and put that into a model that can then be used to detect cars. Another service that they offer is Augmented AI, and the idea behind that is human review workflow. So outliers can take up a lot of time. You will see, just by the nature of it, occasional predictions will look kind of weird, and you're always going to want to go in and kind of figure out, is there something wrong with the model, or is that actually correct how it behaves? But you can end up chasing your tail a lot with doing that. So this service just allows you to kind of automate that process. You can assign workers, and the cool part is you can have a fully automated pipeline with no intervention from your team, but there's still sort of humans in the loop that look at this. You have to provide instructions for how to look at them and the definitions for how to flag which should be go to review. I've never personally used this particular service, but it's interesting, I think, for more robust and more mature models that have been around for a while, you can automate that process. I think in the beginning, it's good to go through that yourself and kind of have your team work through those stuff. You can learn from that. Finally, you have Model Marketplace, which means you can pay for pre-trained models and customized algorithms. It can be helpful for getting good performance for specific use cases. So see the examples here. A lot of it is COVID related. But let's say at ASU, we wanted to set up a camera that estimates the percentage of people that are students that are wearing masks in the library or something like that. Instead of having to develop that from scratch, if we just want to do kind of a use case and see if it's viable and if there's any use for it, we can just rent that model and pay for it, set it up, do a proof of concept, and then present it to someone, and then decide from there. And if we want to move forward with it, then we can develop our own model, or there are other options for that. But it's just a way you can create quite sophisticated proof of concept through that, but with very little upfront investment. So SageMaker then gives the ability to automate the entire model lifecycle. It's not just for managing the moving parts for training and deployment. It can be potentially automated end to end. And that's really interesting, particularly in areas where you have short cycles and high model drift. So think e-commerce, where things change a lot with seasonality, and year over year things can change. You can set something up. You can have model monitors that manages the performance. Once it gets too low, it kicks off or it kicks off a job that picks up a new set of, refreshes the data, retrains the model, deploys them into production, and then it starts going and making productions with the new model. You always want to have a person in the loop there, a data scientist, to just verify everything, but it means that it requires very little manual work that way. And thanks to the AWS cloud infrastructure, this can happen at any scale, even with small teams. You can essentially set up an enterprise level production pipeline from your basement. It doesn't require a lot of setup in the beginning. You can, thanks to the microservices and all of that, you can actually have a 1-person or 2-person or 3-person team actually move the needle and create fairly sophisticated things. So speaking of small teams, we talked a little bit about current SageMaker projects at ASU. So ALEKS is a pilot project that we did. It's daily predictions flagging students at risk of failing based on their activity. So it's currently in production for a smaller selection of online classes. But the idea is to use that to guide intervention, so they can reach out to students who maybe haven't logged in a while, or who start leveling off. They start strong and then start leveling off, and hopefully the model picks up on that and flags them as high risk. Feedback from faculty so far has been good, that it helps them focus attention to smaller subset of students. In the end, the faculty will probably know better than a model. They will have the best insight, but it's just to help them kind of manage their time and manage their focus, and then they can apply their insight on top of that, and then decide if it's worth following through with them or not. But they did mention that it felt like it allowed earlier detection and that it increased chances of successful intervention. Another project that we're currently working on is the persistent model project with the actionable analytics. And it's similar to the ALEKS project, only this time we're focused on term-to-term retention. So ALEKS, we were trying to predict, are they going to pass this class? Now we're trying to predict, are they going to return next semester? And this recreates a model that was previously handled by a third party. And the pilot version that's currently running in production outperformed the third-party model, not by a lot, but by a little bit. And when we first built this and made the first pilot, we were a very small team, and we were just a couple of people. But thanks in large part to the services that we're able to leverage from SageMaker, we were able to show that we can run this in-house, we can get performance that's on par or better than a third party has, and we can probably improve it further. So it speaks to that whole idea that SageMaker and these services can be really helpful in getting proof of concepts together quickly and without too much upfront investment. So in a nutshell, pipelines are important to efficiently both train and manage ML models. It's something that if you're working with machine learning, even if you're more on the training and development side, you'll probably end up finding it helpful to use those in terms of reproducibility and being able to log performance. SageMaker will help you maintain and manage complex ML pipelines at scale. If you were to try to do this, what we're doing now completely manually, especially when it comes to retraining and redeploying models and keeping track of exactly what data was used where and different snapshots, if you were to do that manually, it's a ton of work even at a small scale, and it becomes unfeasible at a higher scale. So SageMaker definitely helps with that. It helps with reproducibility and repeatability. For the reasons that we previously mentioned, everything runs out of S3. So you can almost always dig back and find something in S3 and find the file that was used and the output file and the model that was referenced and the artifacts from those models. You can download those on your laptop and start looking and digging into that if you want to do for postmortem. It allows for small teams to cheaply create enterprise solutions and proof of concepts. And that we've spoken a little bit about already. So in a nutshell, that's kind of the value add that SageMaker offers. And to tie it back to what we were talking about earlier in what that SageMaker adds overhead, I've heard similar from other companies that if all you're doing is doing early model exploring and just kind of playing around, aside from AutoPilot, it may or may not make sense for you to use SageMaker. AutoPilot might actually make sense to get an idea for how it performs, but a lot of the other tools is more once you want to start into the more, you move in a little bit deeper into the development cycle. That's where it really helps and where it really scales and where it really pays off. So we have a few minutes left. If there are any additional questions, I think I was able to get to most of the questions in the chat already.
Yes, we have a total of 4 questions so far. We've answered a couple of them. The 2 from earlier was first was from Super Team Batterjee. Does upgrading the instance type clear the memory inside the system?
Yes, I believe I did answer that, and that's like we said when we talked. If you run out of memory and you need to switch up to a more powerful machine, you have to end that session. So you have to kill that session, upgrade it, and then you have to restart. So it's basically you run your script, you get a memory error, and usually if you get a memory error, the kernel dies anyways, and then you just upgrade it, and then you just rerun your script, and then it should work.
Thank you. And the second question was from Haley Stevens McFarlane. What size EC2 instance do you typically end up using for your models?
Yeah, and we touched a little bit on that. That is mainly between for when I'm working on samples is medium, and with heavier things is anything from large to extra large, sometimes 2x large. I haven't really had to go beyond that except for very experimental things. And the nice thing there is that you can really get extremely as powerful machine as any large company uses, and you can just try it out. And even though they're extremely costly, if you were to use those in the long run, if you just want to see how, try something and see how it performs, running an extremely expensive EC2 instance for half an hour will still only cost you a few dollars. So as long as you're not doing your development work on that EC2 instance, do that on a small instance. And once you're ready to fire off the train command, and you have everything set up down to that, then you switch and you rerun the whole thing, and it can run for 30 minutes, and you get your output and the benefit from that, from a high performance hardware without having to incur all of the costs.
Awesome, thanks for that. That's all the questions I have seen in chat. Everybody should be able to unmute themselves. If you have additional questions, please feel free to speak up.
So this is Aniket. I had a simple question. Kiowa, when you ran your first one-line code, the random forest classifier, so that you'd run on just invoke a Python kernel outside of SageMaker and run it? Is that what we're trying to say?
Yeah, exactly. That one you can run anywhere. So you can run that is run in a Jupyter notebook, and then it's the question where that Jupyter notebook lives. It can be on your local machine, or it can be on SageMaker, on the SageMaker instance. But that's still, it gets a little bit complicated when you think about it, because if you're running it on a SageMaker instance, it's happening locally on that SageMaker instance. And it's not until you send a job over to AWS that that SageMaker truly takes over the processing. So you can still do things locally with Scikit-Learn and other local libraries on that SageMaker instance, just as you would on your local laptop. It's not until you set up all that extra code and actually sends the command over to AWS to get started that SageMaker takes over. And I hope that answers that question, because I think we're at time. I believe it ends at 11:20.
Okay, thanks.
I have to show you the polls that all the participants voted in poll 1 and poll 2. In poll 1, what is the level of familiarity with Amazon Web Services or other serverless technology? 40% of individual voted ever use it. 30% of individuals had to use it a few times here or there. Only 23% of individuals say comfortable with the basics. Finally, 7% of individuals say efficiency AWS certification or accuracy. Finally, poll 2 machine learning. Question 1, what is the level of experience with machine learning? 29% say haven't used it. Also, 29% say same familiarity with basic concept, no professional experience. The most is 39% familiar with mainly data science, but limited or no experience with the deployment side. Only 4% of individuals say help develop production models. I'm going to share the results to everybody on Zoom.
Yeah, I guess it'd be interesting to rerun this and see if anybody moved up a level after the presentation. Hopefully it helped. It helped give some clarity and just an overview of how these things all tie together. And if you have any further questions for me, feel free to reach out by email or Slack. I'm always happy to talk about this stuff. So to reach out.
So I'll just add a quick comment in working with Kiowa. Kiowa, you made it seem nice and easy, which I know AWS sets it up that way, but it's really in large part to your skill and expertise. So I'd say if anyone's interested, a lot of the magic is with Kiowa. So I had to set up a time to talk with him because you laid it out in a great way, but also a big part of where we're at is because of your expertise. So great job today and thanks for sharing.